We compare all the means, and then ANOVA helps to compare these group means to find out if they are statistically different or if they are similar. For the one-way ANOVA, we have only one independent variable, but in two-way ANOVA, we have two independent variables. When the F statistics is larger, then we say that the null hypothesis is disproved, and then there is a need for alternative hypothesis. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 1 of Unit 5, we will be having a discussion on methods of analysis. Now in this, we will be studying about what is ANOVA. So we have all heard ANOVA. So ANOVA is nothing but analysis of variance. So, it is a statistical formula used to compare variances across the means or average of different groups. Now, we all know that whatever the statistics we have collected as a researcher, so we will be applying all the statistical techniques in order to interpret the results of that information. So, we will have to calculate the mean here. So, with the help of ANOVA, we will be able to compare the variances across the means. So, by how much the means are varying from each other. So, what is the mean of sample 1, sample 2, sample 3? Then we have a comparison between the means of the various samples, and for that comparison, this ANOVA will be helping us. So, a range of scenarios use it to determine if there is any difference between the means of different groups. So, what are the means of the different groups? So, here you can see the group variation here, and within the group variation here, and the total variation. So, this will help us. So, this is nothing but ANOVA. So, it will help us to understand the variations between the groups and by variation between the means. We can illustrate with the help of an example. For example, to study the effectiveness of different diabetic medications, scientists design an experiment to explore the relationship between the type of medicine and the resulting blood sugar level. For example, if you can take the example of a science-based experiment here. So, what is the science-based experiment here? So, the effectiveness of the diabetic medication. So, whatever the medicines the diabetic patients take, so how it is influencing the blood sugar level. So, for that they have done a research. So, let us see here. So, the sample population is a set of people. Now, who will be the set of people here? Especially the diabetic patients. So, we divide the sample population into multiple groups, and each group receives a particular medicine for a trial period. So, we have a set of diabetic patients, and so for each set of diabetic patients, we just create groups of them, and each group receives one kind of a medication for their disease. And then at the end of the trial period, the blood sugar levels are measured for each of the individual participants. Now, for each of the individual, now 1, 2, 3, 4, 5, here also 1, 2, 3, 4, 5, here also 1, 2, 3, 4, 5. Now, for each of the individuals, we will be calculating the blood sugar level. Then for each group, the mean blood sugar level is calculated. ANOVA helps to compare these group means to find out if they are statistically different or if they are similar. So, for each group, the sugar levels are measured for each of the individual participants. Then, for each group, the mean blood sugar level is calculated. So, for individual participants, we calculate the sugar level, and then we find out the mean of A, mean of B, mean of C, and then we compare all the means, and then ANOVA helps to compare these group means to find out if they are statistically different or if they are similar. So, the mean groups, the mean of A, mean of B, mean of C, so they are all compared, and then we will be able to say whether they are similar or different. So, in other words, this ANOVA will help us to understand the difference between the means of the various groups and also the comparison between the means of the various groups, and it will tell us what is the statistical difference between the means of each group of the patients given. Then the outcome of ANOVA is the F statistic. So when we compare the means of the various groups, so we get the result. So that result of ANOVA is the F statistic. This ratio shows the difference between the within group variance and between the group variance, which ultimately produces a figure which allows a conclusion that the null hypothesis is supported or rejected. So I repeat here. So the outcome of ANOVA is the F statistic. So the F statistic will be there. Now what is this F statistic? How do I get the F statistic here? It is the ratio of the difference between the within group variance. So I have group A, group B, group C. Now within the group I have 4 or 5 samples. So 6 samples are there in A. Then 6 samples are there in B. Then 6 samples are there in C. So within the group, what is the variance? So I'll be finding the variance within the group and also between the group, that is the variance between A, B and C. So the variance between A, B and C and also variance within the group A, so which ultimately produces a figure which allows the conclusion. So when we have the variances within the group and between the groups, so it will help us to come to a conclusion that the null hypothesis is supported or rejected. So when we get the results of the ANOVA, we can come to a conclusion that the null hypothesis. Now what is the meaning of null hypothesis? So the null hypothesis will tell us whether that medication is useful or not, whether the medicine whatever we have given to the patient, whether it is useful or whether it is working or not. So that we can prove or whether it can be disproved. So if it is supported or rejected, whether the null hypothesis proved or whether it is rejected. So if there is a significant difference between the groups, the null hypothesis is not supported and the F ratio will be larger. So whatever the statistics we are having here, so whatever the variance we get, so that we call it as the F statistics. Now, if the F statistics, if there is a significant difference between the groups, suppose the mean of the group A is 20, the mean of group B is 60, mean of group B is 90. So there is lot of difference between these groups. Then we can say that the null hypothesis is not supported. So the null hypothesis is not supported and the F ratio will be greater. So if we can see here, the ratio between the three numbers, it will be 2:3:4.5 or something like that. So the F ratio will be greater here. So whatever is the outcome of the ANOVA, we call it as the F statistic, and the greater the F statistic means that it does not support the null hypothesis. So if the F statistic or the F ratio is small, then it means that the null hypothesis is supported. Then the next, we have certain terminologies in ANOVA. Let us get familiar with the terminologies here. The first one is the dependent variable. Now what do we mean by dependent variable? This is the item being measured that is theorized to be affected by the independent variables. So we have the independent variables here and the observations here. So then we have the observations of group 1, group 2, group 3, group 4. So the dependent variable means, so this dependent variable is affected by the independent variables. That means, suppose going back to the example of the diabetic patients, so the dependent variable will be the level of the blood sugar. So it will vary based on the medication you are giving to the patients. So that becomes the dependent variable. Next, independent variable. These are the items being measured that may have an effect on the dependent variable. So these are the items that are measured that may have an effect on the dependent variable. Next, the null hypothesis. Now, how do we just define null hypothesis? This is when there is no difference between the groups or the means. So, depending on the result of the ANOVA test, the null hypothesis will either be accepted or rejected. So, as I had explained earlier in the previous example I gave you, so if the F statistic or if the group mean differences is very small, then the null hypothesis will be accepted. If the differences will be very large, then the null hypothesis will be rejected. Now, what is this hypothesis? Hypothesis is the expected result of the research. So, when the researcher is undertaking the research, he will expect that he will get a certain result. So, that result which he expects, so that we call it as the hypothesis, and with the help of this ANOVA, we will be able to see whether this null hypothesis has been proved or disproved. So, alternative hypothesis. When it is theorized that there is a difference between groups and means. So, when the F statistics is larger, then we say that the null hypothesis is disproved, and then there is a need for alternative hypothesis. So, the symbol for null hypothesis is HO, whereas the alternative hypothesis is H1. So, in this way, we can say these are the various terminologies used in ANOVA. Then, factors and levels. In ANOVA terminology, an independent variable is called a factor which affects the dependent variable. The level denotes the different values of independent variables that are used in the experiment. So, in this ANOVA terminology, so the independent variable is called as the factor. And what is the level? So, level is the different values of independent variable. So, different values of independent variable are called as levels, and independent variables are called as the factors. Now, the next one is the fixed factor model. Some experiments use only a discrete set of levels for factors. For example, a fixed factor test would be testing 3 different dosages of a drug and not looking at any other dosages. So, a fixed factor means, so some experiments use only discrete levels for factors. So, you are here, the level is 3 dosages, 3 different dosages of a drug, not looking at any other dosage. Then, the next one is the random factor model. So, this model draws a random value of level from all possible values of the independent variable. So, it will draw the value of level from all the possible values of the independent variable. Then, next, types of ANOVA. What are the different types of ANOVA? The first one is the one-way ANOVA. So, what is this one-way ANOVA? The one-way analysis of variance is also known as a single factor ANOVA or simple ANOVA. So, one-way ANOVA is the single factor. So, there is only one independent variable here. As the name suggests, the one-way ANOVA is suitable for experiments with only one independent variable with 2 or more levels. For instance, a dependent variable may be what month of the year there are more flowers in the garden. So, there will be 12 levels. A one-way ANOVA assumes. So, a one-way ANOVA, as I had told you earlier, it is analysis of variance where there is only one single factor with 2 or more levels. But here, for instance, the dependent variable may be what month of the year there are more flowers in the garden. For example, if you are taking the number of flowers in the garden, So for every month, there will be the number of flowers may increase or decrease. So depending on the output of the plant, and that is what we have the called as the 12 levels. So if we are having a survey of number of flowers in the garden, for each year we will have 12 levels. That is, for every month we have the level of flowers in the garden. Next, what is dependence? So what are the assumptions of ANOVA here? So in this, the first one is independence. The value of the dependent variable for one observation is independent of the value of the other observations. So the independence is, so one observation is independent of the other observation. So for example, when you toss a coin, we may get a head or a tail. So that outcome is as special as the next time you toss a coin. So the next time we toss a coin also, it will be an independent event itself. So both are not related. The same way here, the observations are independent of the value of any other observations. So the value of the dependent variable is normally distributed. What is this normal distribution? So normal distribution means, so we have the highest range and the lowest range, and all other values will be in the center point. So this we call it as the normal distribution. So the value of the dependent variable is normally distributed. Then variance. What is variance? Variance is comparable in different experiment groups. So when we are researching the various groups, then we will be calculating the variance. Then we have this continuous. The dependent variable or the number of flowers is continuous and can be measured on a scale which can be subdivided. So the dependent variable is continuous and it can be measured on a scale. Then the next one is the two-way ANOVA. Now what is this two-way ANOVA, or we also call it the full factorial ANOVA? What is this full factorial ANOVA? It is used when there are two or more independent variables. So for the one-way ANOVA, we have only one independent variable, but in two-way ANOVA, we have two independent variables. Each of these factors have multiple levels. So full factorial ANOVA can be only used in the case of a full factorial experiment where there is use of every possible permutation of factors and their levels. So this kind of a ANOVA is used when there is every possible permutation of factors and their levels. This might be the month of the year when there are more flowers in the garden, and then the number of sunshine hours. So this two-way ANOVA not only measures the independent versus dependent, but if the two factors affect each other. So two-way ANOVA. So here we can say that in a two-way ANOVA, there are two independent factors. Suppose again you are researching on the number of flowers in the garden. So there will be two independent variables here. One will be the month of the year. So what month of the year we are having the flowers, and second one will be the duration of the sunshine on the garden. When we analyze these two factors, we have this two-way ANOVA. Then this two-way ANOVA assumes continuous. That is the same as the one-way ANOVA. The dependent variable should be continuous. Then second one is independence. Each sample is independent of other samples with no crossover. Then variance. The variance in data across the different groups is the same. The normalcy. The samples are representative of the normal population. Categories. The independent variables should be in separate categories or groups. Next, now what is the need for ANOVA? Some people question the need for ANOVA. After all, the mean values can be assessed just by looking at them. but ANOVA does more than only comparing the means. So there are people who are arguing that what is the necessity for ANOVA? So we can always see the means of all the groups and then compare and come to a conclusion. But then there are statisticians who say that ANOVA is more than comparing the means. So even though the mean values of various groups appear to be different, this could be due to sampling error rather than the effect of the independent variable on the dependent variable. If it is due to sampling error, the difference between the group means is meaningless. So ANOVA helps to find out if the difference in the mean values is statistically significant. So here, what is the extra thing what the ANOVA will do? So the ANOVA will help us to find out if there is the difference in the mean value is significantly, statistically significant. So if it is due to sampling error, the difference between the group means is meaningless. So when you are comparing the means of each group, that is group A, group B, group C. So we have the mean of A, mean of B, mean of C. Now when you compare the means of various groups and find out that the difference in the mean value is statistically significant, so this means that this ANOVA will help us to find out whether there is a significant difference in the mean values of the various groups. So if it is due to sampling error, the difference between the group means is meaningless. Now this, if there is a sampling error, now the sampling errors we have learnt in the previous chapter itself. So if because of sampling error there is a mean difference, then that mean difference is meaningless. But if it is due to the statistically, if the means are statistically significant, that we can know only with the help of this ANOVA. Then next one, ANOVA also indirectly reveals if an independent variable is influencing the dependent variable. For example, in the above blood sugar level experiment, suppose ANOVA finds that group means are not statistically significant and the difference between group means is only due to sampling error. So this result infers that the type of medication is not the significant factor that influences the blood sugar level. So with the help of ANOVA, we can also come to a conclusion that difference between the means is due to the sampling error, and as a result of which it is not a significant factor. The medication whatever we have given to the patient, it is not a significant factor which is affecting the blood sugar level. Then next one is limitations of ANOVA. So ANOVA can tell if there is a significant difference between the means of at least two groups, but it cannot explain which pair differs in their means. So if there is a requirement for granular data, deploying further follow-up statistical processes will assist in finding out which groups differ in mean value. Typically, ANOVA is used in combination with other statistical methods. So, what are the limitations of ANOVA? It will just tell us the difference between two groups, but it can't explain which pair differs in their means. So, if you have A, B, C and D, so it will tell what is the significant difference between two pairs, but then cannot explain which pair differs in their mean. And if there is a requirement for granular data, so if you want to have minute data, then it will not help. So this ANOVA is used in combination with other statistical methods. Then ANOVA also makes assumption that the data set is uniformly distributed as it compare means only. If the data set is not distributed across the normal curve, then there are outliers, then ANOVA is not the right process to interpret the data. So what are the assumptions of ANOVA? ANOVA assumes that the data is normally distributed. There is uniform distribution of data. But then if there is no uniform distribution of data, then ANOVA cannot be adopted. Similarly, ANOVA assumes that the standard deviations are the same or similar across the groups. So if there is a big difference in standard deviations, the conclusion of the test may be inaccurate. So it assumes that the standard deviations are same or similar. So when there is a comparison between A, B, C and D, and then it assumes that the standard deviation between them are the same or similar across the groups. So if there is a big difference in standard deviation, then the conclusion of the test may be inaccurate. Then, how is ANOVA used in data science? So one of the biggest challenges in machine learning is the selection of the most reliable and useful features that are used in order to train a model. ANOVA helps in selecting the best features to train a model. It minimizes the number of input variables to reduce the complexity of the model, and it helps to determine if an independent variable is influencing a target variable. So, in this way, ANOVA will help us. Then, an example of ANOVA use in data science is in email spam detection. So, because of the massive number of emails and the email features, it has become very difficult and resource intensive to identify and reject all spam emails. So, ANOVA and F-tests are deployed to identify features that were important to correctly identify which emails were spam and which were not. With this, we come to the end of this session. Hope you have all followed it. Thank you.